How the universe will end, a journey into the future. Welcome, space lovers. Today, we're diving into a mystery as old as the cosmos itself, a question that has captivated humanity for centuries and might just leave you in awe. How will the universe end? We already know how it all began, with the Big Bang. But endings? Endings are far more enigmatic. In this video, we'll explore the leading theories behind the ultimate fate of the universe. From chilling freezes to cosmic collisions, we'll investigate the far corners of the cosmos and journey into the deepest future imaginable. As we delve into these mind-bending possibilities, one thing becomes clear. The final chapter of the universe is as majestic as its very existence. Buckle up, because it's going to be an unforgettable ride. To talk about the end, we first have to understand where we stand today. Picture a vast expanse filled with billions of galaxies, each home to trillions of stars. Between them lies darkness, a mysterious fabric we call the universe. But it's not static. Our universe is expanding. Galaxies are drifting away from each other, carried by the cosmic tide of dark energy, a force we barely understand but know is accelerating this expansion. Alongside dark energy, there's gravity, the architect of galaxies and stars. Then there's entropy, the relentless march of disorder. Together, these forces shape everything in the cosmos, and as we'll see, they might dictate how it all ends. The first theory we'll explore is called the Big Freeze, and it goes like this. The universe will keep expanding forever. Over time, stars will burn through their fuel and die. Galaxies will dissolve into isolation. The elemental building blocks of existence will spread so far apart that even heat dissipates completely. Imagine a universe where there is no warmth, no light, no activity. It's just frozen in time, a cosmic tundra. Life, stars, and galaxies rely on energy to thrive. But in a Big Freeze scenario, the universe enters a state astrophysicists call heat death. Despite the name, it's not about fire. It's about the complete equilibrium of energy. When energy evenly spreads across infinite space, everything just stops working. In this frozen expanse, individual atoms might survive for a while, but even they would break down eventually, leaving an infinite cold emptiness spanning countless eons. It's a haunting thought, a universe without activity or change, a silent graveyard of stars and galaxies. The next possibility on our journey is a much more dramatic conclusion, the Big Crunch. Instead of expanding forever, what if gravity stood up to dark energy? What if the universe, instead of accelerating outward, began to slow down? This scenario envisions a universe that reaches a tipping point, where the attraction of gravity overcomes the push of expansion and pulls everything back together. Galaxies would collide, stars would smash into one another, and all matter would be compressed into an unimaginably dense point. It's the reverse of the Big Bang. Sounds catastrophic. It is. Temperatures and pressures in this cosmic implosion would become extreme, obliterating the structures we know. Time and space themselves would cease to exist as we understand them. But there's a silver lining to this fiery end. Some scientists believe the Big Crunch might not be an end after all. Instead, it could lead to another Big Bang, a rebirth of the universe. In this way, the cosmos becomes not a linear story with a beginning and an end, but an eternal cycle of death and renewal. If that's true, the universe could be infinitely reimagining itself, like a phoenix rising from the ashes. Next on our journey is a theory that is closely linked to the Big Freeze, but imagined over an even grander timescale: heat death. To understand this theory, let's revisit entropy, the idea that everything in the universe trends toward disorder. Every star that shines converts fuel into heat, increasing entropy. Every black hole that devours matter does the same. Over time, the energy we rely on to power stars, planets, and life becomes more scattered, less useful, and more chaotic. In a heat death scenario, every star burns out. Black holes, which are initially the last fierce forces, eventually evaporate, radiating away their mass into the void. Even the tiniest particles, like protons, decay into nothingness. This process takes trillions upon trillions of years. At the end of it, nothing cohesive remains. There's no movement, no heat, and no possibility of interaction between particles. The universe becomes a static, cold, empty expanse. A universe where time and change themselves might as well not exist. It's a slow, unrelenting fade to black, and possibly the ultimate fate of everything. Now let's turn our attention to perhaps the most violent and visually stunning theory, the Big Rip. This possibility is fueled by dark energy, the mysterious force driving the universe's accelerating expansion. But what if this acceleration doesn't slow down? What if instead it speeds up to the point where it becomes unstoppable? In the Big Rip scenario, dark energy would grow stronger and stronger, overwhelming not just galaxies and stars, but even the forces holding atoms together. First, galaxies would be torn apart, unable to resist the relentless pull outward. Then solar systems would be unbound. Then planets and even atoms themselves would be ripped apart. The very fabric of space and time would unravel in the blink of a cosmic eye. This could happen suddenly, leaving no chance for anything to survive the cataclysm. It's a universe so consumed by darkness and energy that it tears itself asunder. A violent and dramatic ending compared to the slow fades of the other theories. The horrifying beauty of the Big Rip is that it shows how the very forces that expand the universe could also destroy it. The theories we've explored, Big Freeze, Big Crunch, Heat Death, and Big Rip, are rooted in the scientific knowledge we have today. But what about the ideas still beyond our grasp? Some physicists wonder if the universe's end might trigger the beginning of something completely new. Could a black hole from one universe birth a Big Bang in another? Could collapsing dimensions spawn alternate realities? Others suggest that the death of the universe might not be the true end, but a transformation. Maybe the fabric of space and time contains traces of future possibilities invisible to us now. We don't have answers, but that doesn't stop us from asking questions. That's part of the magic of science. It thrives on curiosity and imagination. So, what does the end of the universe mean for us? For humanity? For a tiny speck of life on a small blue planet, orbiting a star in a middle-of-nowhere galaxy? The end of the universe reminds us how temporary and precious our existence really is. Our lives unfold on an immense stage, nestled between a brilliant cosmic origin and an unknowable conclusion. But more than anything, these endings remind us of how much we've yet to learn. The universe, we ourselves, are part of this incredible cosmic story. Whether it ends in a blaze of fiery collapse or the quiet hum of heat death, it's the journey and the discoveries along the way that matter most. From the freezing silence of the Big Freeze to the violent shredding of the Big Rip, the ultimate fate of the universe is as varied as it is fascinating. The exact ending may remain a mystery for now, but one thing is certain: studying the universe's end is as much about understanding our place in the cosmos as it is about the universe itself. So next time you gaze at the stars, think about this. They're not just dots of light. They're part of a grand story, one that began with a bang and will end someday in a way we may only dimly understand. Until then, let's keep looking, keep asking, and keep marveling at the beautiful enigma of the universe. Thank you for joining us on this incredible journey through time and space. If you enjoyed this exploration, don't forget to share your thoughts in the comments below. See you next time, Space.